can get power, so I'm going there. And then even for us as the entity that needs to go and get the power, bring it on site, power the innards of the facility, it's a crazy negotiation process with power utilities where they say, well, you'll tell you what, if you need 200 megawatts, you'll pay us for 200 megawatts whether you're using it or not, right? And hopefully you do and say, well, gee, the customer hasn't really agreed to do this yet, but I can get them to agree to do this unless I have the power. And it goes back and forth. So power is really the thing. And I just wanted, if there's any of the folks from the previous panel in the room, you need to get your costs of green energy and alternative energy down by like 70%. You really do. Love you. It is the future, but you've got to get those costs down because the other thing we're seeing is 10 cents a kilowatt is basic home utility power rate. Get it cheaper if you buy it in bulk, right? But the cost of those alternative energy sources is double or triple that. And nobody's going to pay that. I shouldn't say nobody. If you're really in a bind, you'll pay that. But it's tough, right? So power's the thing.
Yeah. It's funny, I've heard that nuclear is definitely the power source of the future, and it always will be.
I struggle with the idea of fissionable materials on my campus right now.
Right. Are you seeing the same thing? Is power really the thing that is one of your biggest challenges?
I would say it differently. I think you always hear supply and demand. I would say capital, time, and demand are the things that we're struggling with. And so when you consider, even I just started with the business in January. At that time, most of our data centers were 10,000 square foot, 2 megawatt kind of facilities that were coming on board. What we're building now in the next design would be 45,000 square feet, 6 different 7,500 square foot data halls with 2 megawatts, 3 megawatts, or 6 megawatts, depending on the workloads that you're putting into those facilities. That's a dramatic difference from where we had been before. And whatever number you want to use, but just for easy math, I'll say, $10 million a megawatt times 36 so now we've got 360 million going into a specific facility, which is more capital than most of the edge data centers that are alive today that haven't jumped into the hyperscale space have spent up till now.
Right.
And that's one. And we're kicking off 3 of those builds right now. So when you think about the amount of capital that's required, I think you have an issue where the hyperscalers have sucked so much oxygen out of the room related to the capital required to do it. And they're absolutely right. But I also think that you have a unique group of investors that are saying, I missed out on the hyperscale space. I can do an Edge Connects because I'm Abu Dhabi and I'm writing $1 billion+ checks to them. But there's a boatload of large PE and infrastructure funds that have missed out that I think are really interested in investing in something different than hyperscaler, which presents an interesting opportunity for us. And the belief that time and demand is really the bigger issue. You have to have the money, you have to be able to build it, and then demand just keeps coming. And so I think that's the thing that we're really struggling with more than generating power or getting power right now for us.
Yeah. How about you, Scott? How's Dartpoints seeing the power as it impacts your growth trajectory going forward?
Yeah, well, let me not zero it in on just power, right? So, yes, power is obviously one, but again, very much like Brett was talking about, where we play and how we think about the market. We're not looking at 300, 400, 500, right, megawatts of power, right? That's not where we play. We're trying to size it more like Brett does, which 20 may be, but let's just call it 20 and down. And so it's not just a power challenge, right? It's across the entire ecosystem. Let me even amplify it beyond just growth, right? So we've got a platform today, very much like Brett was just talking about, that let's just call it supports a standard workload in 5 to 7 kilowatts a rack, right? That's where we are today. Well, even for me to be relevant in 3 to 5 years from now, where workloads are going, if I don't evolve that existing platform, right, to 12 to 15 to 18 kilowatts a rack, I'm going to be irrelevant and I'm going to start losing my customers. That's driving a certain capital demand and retooling of an existing platform that, in my belief, if you're a data center operator today and you're part of that leadership team, if this isn't on your weekly meetings as a leadership team, I think you're in a challenging situation. That's driving a certain amount of demand, just retooling that platform. And then now let's get on the growth side, the expansion side, right? Which is a little bit about what Brett was talking about earlier, right? That's where we see tailwinds. We see these larger workloads, these opportunities. We want to build and expand facilities to meet that, right? So when you're a company like Dartpoints, and you're looking at what you need to do as a business to evolve the platform strategically, you've got a lot of competing drivers there. So where I don't struggle so much with power, because I'm not looking for 300 megawatts, if I've got to increase power off a substation and I've got to work with a power company, yes, I do that. But mine is everything. It is electronics, it's generators, it's cooling, right? I've talked with Jeff at DC BLOX. These guys got a lot of generators that are ordered. I can't go out and order 60 generators, right, and buy at volume where I can get an accelerated track. I don't have that kind of volume across my platform. So the entire ecosystem, it's not just power, it's every element of what it takes either to evolve my existing platform or expand to meet the needs of future workloads. All of that is competing in terms of time. So power is there for me, but it's almost every element in the supply chain is a constraint in terms of how quickly I can bring capacity or evolve my platform into market. So in many ways it's an exciting thing because there's opportunity and we're all in an exciting space. But it's not without its challenges. And how do you get from where you want to be to where you want to go and build and drive your business? Because there's a lot of hurdles you got to cross.
Yeah, I mean, when we look at the data center inventory levels being at historical lows, right, and the demand being at the height that it is right now, you do have to, I think, look at the stratification of the data center community. So you've got pure play build-to-suit providers, right, that are designing an entire campus at 300 plus megawatts to fulfill an individual workload need. But then those other workloads haven't gone away, right? So they've got to filter through the process. Do you feel like you know where you need to be a year from now? And what are the challenges to get to a year, 3 years, 5 years from now to be able to fulfill what you see as your spot in that overall architecture? Maybe we'll start at the other end this time.
So I think the answer is we think. We think we do. And it's really how open are your partners going to be with you? So, pick on Dell for a minute. So, Dell's got a new AI stack, effectively with the GPU setup they're talking about 12 kilowatts per, and they want to put 4 in a rack. So now we're at 48 kilowatts into the comment that was just made. That's 10 times per cabinet that you have in the other side of your data center. Those enterprise customers are coming to us saying, I'm having this conversation with Dell. There's no way in hell this is going in my building if I have my own data center. And sometimes my current data center provider doesn't have the available power to go into it. And the hyperscalers won't talk to me because they're not 100 megawatts. And so for us, what we're thinking is, okay, and it really led us to the kind of this, I don't want to call it modular, I'll call it scalable design. From the standpoint, we might have a customer that comes in with an HPC environment and a mix of other stuff, and 2 megawatts in a data hall for them is great. But then we have another customer that coming in and saying, I think I'm going to need 12 over the next 24 months, and I want them contiguous because the cost of infrastructure to put all my fiber and everything else, they need to be right next to each other, so I'll make a demand for that. And then that's what's led us to looking at much bigger opportunities where we're building larger shells with different size halls. All of that, I think, has to be done, or you're going to be left stranded. You as the provider and the customer, because there's really not enough places to go put that. There's, especially in our sweet spot of data center size, there's a number of people that have been more focused on cloud than co-location for the last 5 to 10 years and haven't been investing. And if they haven't been, to your point, ordering generators a year and a half ago, they're way into the future before they can dream of trying to keep up with what the customer demand is. We're seeing customers come to us now with, not large language models, but small language models that they may literally have bought a single GPU, shoved it in a server under somebody's desk, and they're playing with it. And they're putting a budget together for 2026. And so right now they're wanting to say, do you have the power? Do you have the cooling? Could you help me understand liquid cooling as well? And if we're not prepared to have that conversation, I think that it's the enterprise customer that's going to suffer more than anybody.
Yeah,
Scott?
I mean, I echo all of that. Obviously, our businesses are similar in terms of how we go to market and what we're targeting, and we're facing similar charges or challenges. I think you're right. The biggest piece for a business like ours, where we're trying to serve more of an enterprise, or we're trying to play a little bit in that AI space or that HP space in kind of that 20 megawatt and down, because I think there's a real vacuum in the market, because some of the larger players, I'll reference Raul at DataBank. He and I live in Dallas. We talk a lot, and he won't even look at anything below 40 or 50, right? So there's a real vacuum, and we're trying to solve for that. But the real challenge is, historically, looking backwards, you just kind of built a data center with 4 walls that was kind of air cooled, and you could meet the needs. And nowadays, when you're in a space where we are, and all the constraints, particularly on capital that Brett was talking about there, is how do you design a facility, right, that meets the needs of all the various workload demands and customers within that facility, right? And so how you think about halls. Well, we're going to do this hall, we're going to do this direct to chip, and we want to be able to support up to potentially 50, maybe 80 kilowatts a rack, right? And you kind of carve that sector off, and then you go, well, I've got more mainstream that maybe that's going to be 15, 18, maybe 20 kilowatts a rack, so I'm going to design that. But then it's bets on our part, right? We've only got so much capital. We think we understand the market. We both think we have a plan, and not knowing what's the right configuration to absolutely take advantage of the workloads that are in the market is a challenge for us as we look forward. It's some of it's part of the fun, right? It's kind of exciting, but if you miss, right, it can be costly, and that's it's just where we are on where the market is and the types of opportunities that are in front of us.
Jeff, how's DC BLOX looking at the same thing?
You said you echo the comments. I'm going to echo the comments.
Yeah.
Echo the comments. It's a complicated equation to understand where the market's going, to understand the technology evolution, to understand how you're going to deploy the technology. Where do you make your bet? And I think we've recently, Google comes in very specific about what they want, and that makes it easier to build a data hall or a campus for them and just get that done. Their power requirements are clear. Exactly how many kW per cabinet is clear. So then it's more like almost like the Tetris problem. You just have to make it all fit in the same building rather than understand, well, what's my good mix of power to cooling in this hall. We've adopted a model which is, all right, that's going to be the hyperscale, 100,000 square foot building, and that's going to be the 10,000 square foot retail building next to it. Right. And we can size those differently and use different technologies along the way. We've also adopted, chilled water technology right to the cabinet, so we can get those 50, 80 kW per cabinet workloads serviced and keep them cool. No longer can do it with air, obviously. That era is 10 years ago. So, it is a moving target. Capital, to your point, is hard to find. Although when you have a 20-year agreement from a hyperscaler, it makes it easier to get funding to build that, right? So it's an interesting space. It's evolution. I focused on power in my first comments because that to me right now is the pain point. But there are 53 pain points, right, in getting this done, and you have to serve all 53 of them. And it's not just technology. It's not just deployment. It's not just maintenance. Because if you look at our website, we've got these renderings of the campuses that we're building, and the generators just go as far as the eye can see. And those things have to be exercised regularly. There's the story about when they paint the Golden Gate Bridge, right? They start at one end and they paint it, and then when they're done at that end, they go back to the other end and start again because it takes that long. That's the same thing we're looking at in terms of staffing and maintenance for these facilities. There's generators as far as you can see, and they have to be exercised, and that doesn't happen in 5 seconds. So we think the team's going to start at generator 1, exercise it, do maintenance on it, and by the time they get to generator N at the end of the chain, it's time to start over again. So there's challenges in all of this, and I find it crazy exciting. Right? It's so much fun to think about the scale of this and how we're going to adapt and change, because the rules of 5 years ago, even you have to say the rules of 20 years ago no longer apply. Well, that's clear. Right. The rules of 5 years ago no longer apply. I also wanted to pile on one other thing. We talk about these campuses that are tens or hundreds of megawatts and all the cool things that they're doing in there. Sometimes it's the government you don't know. Sometimes it's Google, and you do know, right? But the next piece is there's a whole pile of information there, and it can't just sit there. You can't be islanded, to your points earlier. So we have in the last few years also become a fiber construction company. So we're digging trenches, we're laying fiber, and we're selling it to customers either as conduit, to your point, or just fiber that we sell them dark fiber that they will light. So we recognize that it's this symbiosis between the data center facility itself and also the demand or the requirement to get information into that facility and out. If you're a hyperscaler, you mirror this information around the planet, and you have to get it there that fast. So we see at the same time, with growth in terms of power and cooling and everything in the physical data center, a crazy demand for connectivity. Meta is sticking 832 count fibers in the ground everywhere, and you can do sort of 30, 40 terabits on a pair. So you do the math, it's like, this is insane. Well, maybe it's not insane, it's super cool, but again, the scale of this is just mind-numbing and extremely cool. But connectivity is the synergist, right? You can't just have the data center, it can't be an island, you have to have the connectivity. And the hyperscalers are becoming their own telecoms. They get frustrated, I'll say AT&T, but pick the telecom carrier you hate the most, right? The hyperscalers have become frustrated with those telecom providers. They're like, we're not gonna use you anymore. And they're building their own networks, they're laying their own subsea cables. Right, we've just, it's been in the press in the last 6 months. We built a cable landing station in Myrtle Beach, South Carolina. Cable goes to South America. Google owns the cable. Google owns the cable. They have so much money in the bank. They're putting subsea cables on the ocean floor. So there's a whole shift in paradigm along this whole ecosystem. And again, I find it crazy, compelling, and exciting, but it is a daily challenge to innovate.
Well, talking about different processes, I'd like to just piggyback on what you said there and raise a couple of questions. Again, when I go back 10 years as a communications infrastructure developer and provider, we felt more like a customer of a data center. We were enabling the tenants of those data centers, but effectively we were a customer. We came in, we took space, we then interconnected and farmed the customers of the data center itself. And today, that paradigm is changing, to exactly your point, because the data center operator themselves, a DC BLOX, is also a communications infrastructure provider.